Now this one here, if you can do it, is a really, really nice question. There are 4 marks available, and the first step I used was to basically say that the PD is equal to current times the total resistance. So I found out the total resistance of all of these resistors here. So RT is equal to V over I, which is 45 over 0.030, which equals 1500 ohms. So a nice number there. So effectively, the combined resistance of these 3 resistors is 1500. What I then did was I basically said, okay, let's imagine that effectively we've got resistor 1 and resistor 2. So this is R1 and this is R2. So what I wanted to do was if I knew the total resistance and I knew the resistance of this, what's the combined resistance of R2? Where R2 is basically the combined resistance of the 750 ohm resistor and the resistor which is R. So I said that RT equals R1 plus R2. We know that the total combined resistance is 1500. We know this is a value of 1000, and therefore the combined resistance of these 2 resistors is equal to 500 ohms. So that's the first part. The second part was I said, okay, you've got 750 and R, their combined resistance, we'll maybe call it, RT. Now, effectively, RT, well, you've got basically R1 and R2. So 1 over 500, which is what I found out over here, is equal to 1 over this resistance plus 1 over that resistance. So 1 over 500 equals 1 over 750 plus 1 over R. So 1 over R equals 1 over 150 minus 1 over 750. Take the reciprocal of it, which is what people forget to do. And I found that R is equal to 1500 ohms. So hopefully that makes sense. But I thought that if you know about resistors in parallel and series, there's some very, very nice marks for you here. 5b then. Okay, you need to know about your practicals. Okay, there's absolutely no excuse. You might not have done this experiment yourself, but there's something that, this is mentioned in the specification. So first of all, you've got basically loads and loads of information. You've got a DC power supply. You need to draw the circuit. You've got a voltmeter or an ammeter. I chose to use a voltmeter, just that's what I did. You've got an LDR. You've got a there we go, and a resistor. So basically you've got loads of stuff here. The first thing, I drew my circuit. Now this thing here, I made as large as I could. I used a ruler because, I only need to draw one of them. And really, in your exam, I know I did it in pen to make it show up here, but use a pencil because if you make a mistake, you can rub it out. So here's my DC power supply. Here's my resistor, and here's my LDR. Now you should know what the symbol for an LDR is. You probably learnt about it maybe in year 10. Okay, so that's all straightforward, but which one does the resistor go over? Well, you've got to think about what happens to this LDR. Basically, as you've got resistance here and you've got the light intensity up here, as the light intensity increases, the resistance of the LDR decreases. And that means that the share of the potential difference across the LDR goes down. So as the light gets bigger and bigger, this resistance goes down, and that means this has a greater share of the potential difference. And so that means the potential difference reading goes up here, which is what we want, because we want to know that the meter must rise when the light intensity increases. So I've got my circuit, and why not draw a graph to kind of show this? So I've said that, and you probably need to put this into a few more words. As light intensity increases, the resistance of the LDR decreases. So the PD across the LDR decreases, which means the PD across the resistor must increase, because their combined PD must equal the EMF of the supply. The next bit, the sort of last kind of 1 or 2 marks, basically says that the largest change in the reading on the voltmeter is when the resistance is small. Okay, and therefore you should choose the smallest resistor, which is the 750 ohm resistor given to you from A up here. Now this question here, it's not too bad. There's a lot of reading to do, but underline the key words. Draw a big diagram, maybe draw a graph as well, and then think about a step-by-step approach to your answer. So maybe you get a couple of marks here for the right thing here, the right symbols, a couple of marks for talking about how as the intensity of light goes up, this resistance here goes up, the PD across it goes up, and then a bit about the final bit, which do you get the biggest change for. Okay, so that was part B, and the next video is all about question 6.